Now in question 9, the angles are in radians. Now, in a properly written paper, you notice that straight away because the angles will have no degree signs on them. That indicates it's in radians without even seeing this part at the side, which is handy because I don't like writing the degree signs in anyway. Well, it's a double angle equation. One angle is double the other. I'll have to make them both the same, so I'll have to change that into an equivalent form involving sine in this case. So 1 minus 2 sine squared theta plus 3, sine theta minus 2 equals 0, and then just sort that out. So you can think of either taking over reading backwards or just sorting out and then flipping the signs. So that will be 2 sine squared theta, flipping the signs, minus 3 sine theta, and that would have been minus 1, so it's plus 1 equals 0. Quadratic in sine, factorise it. So given that it does factorise, it must be 2 sine theta times theta. It must be 1 times 1. The negative must go to the larger, and that says they're both the same anyway. So what we've got then, if that factor is responsible for being 0, then sine theta would have to be the opposite of that, which is 1 over 2. Or, if this bracket was responsible for being 0, then sine would have to be the opposite of that, which is 1. And these answers you know immediately, and you can just write down straight away. For this one, theta would be, but I'll illustrate it again with the quick graph. The graph of sine looks like this. When does it get to the top? When does it get to 1? At 90 degrees, which is pi upon 2, because it wants it in radians. This one here, you recognise the half. You should know the half is 30 degrees, which is pi upon 6. If you don't remember it, draw the triangle out. 1, 2, root 3. 1's opposite the smallest, which should be 30. We'll change it into radians. Pi upon 6. So the other one's going to be the pi upon 3. And the other angle would be, again, you know it's going to be 180, that away from 180, but, or that's in degrees though, or you could just think of it, all sine, tan, cos. It's either going to be there or there for a positive sign. So that's the pi upon 6. That's pi all the way around, which is like 6 lots of that. So if that's 1 lot of pi upon 6, and that's 6 lots, then that must be 5. 5 pi upon 6. But again, all of that can be done without doing any of that at all, because you know all these answers. So the angle's going to be, put them in order, pi upon 6, then pi upon 2, and then the 5 pi upon 6. Just keeping it all in radians. It's easy enough to do all in radians without having to do it in degrees and then translate it afterwards. Good practice. Part B, another double angle one. This time I want to change it into the cos form for that one. So that will be 2 cos squared theta minus 1, then minus 4 cos theta minus 5 equals 0. Tidy that up. 2 cos squared theta minus 4 cos theta minus 6 equals 0. May as well take out those 2's just now. Cos squared theta minus 2 cos theta minus 3 equals 0. Always easier if you're going to factorise a quadratic to try and get that coefficient down as low as possible. And then simple in this case. Given that it does factorise, it can only be cos times cos and 1 times 3. The negative must go to the larger, so that'll be a plus there for the opposite sign at the end. In which case, if that bracket's responsible for that 0, if that factor's responsible, cos theta would be negative 1. If that one was responsible, then cos theta would have to be 3. But that's quite handy, because cos can't get as high as that. Again, you can just visualise this in your head and answer this immediately, but I'll put it down. Cosine looks like this for its first cycle. It only gets up as high as 1, down at negative 1. It never gets to 3, so for this part there's no solution. For this part, when does it get down to the bottom? That's halfway along. That's when theta equals pi. So I can just finish it off. So what's the value of theta? Only pi. There. Part C. Double angle, changing a cos to match a cos. So that will be then, I'll go for 2 cos squared theta minus 1 is cos theta minus 1. Well, those can go. So I'm just left with 2 cos squared theta minus the cos theta equals 0. Having on one side so I can factorise it, and it factorises readily via a common factor cos theta, leaving 2 cos theta minus 1 for the other factor. And And then, if the product of those factors comes to 0, either that factor is 0, in which case cos theta is 0, nice and simple, or that factor is 0, in which case cos theta would have to be opposite divided by 2, which is a half. Again, you know these, you could just put them down straight away without reference to any diagrams at the side. I know that cos theta starts at the top, goes down at 90 and back up at 270, so that means that theta is going to be pi upon 2 for the 90 and 3 pi upon 2 for 3/4 of the way along for the 270, or that the cosine of 60, which is pi upon 3, is a half, so theta is going to be pi upon 3, or the other time would be the opposite end away from 360, which is 2 pi, which is 6 lots, so that would be 5 pi upon 3. I could just state that and then put them together, or I could illustrate it like this. What about this cosine equal to 0? Well, the cosine graph looks like this. When's it equal to 0? Here and here. Remember, that's 2 pi. So that's 1/4 of the way and 3/4 of the way. Pi upon 2, 3 pi upon 2. The half, if you can't remember which one gave the half, remember the triangle instead. 1, 2, root 3. One's opposite the smallest, that'd be 30. That's the pi upon 6. This would be the 60, the pi upon 3. So if the cosine's a half, that means you're looking for the adjacent side. Which angle is 1 adjacent to? That's the pi upon 3. So that's one of your answers. The cosine's positive, all sine, tan, cos. So I'm either in the first quadrant with my pi upon 3, or I'm in the fourth quadrant with my pi upon 3. So I'm either pi upon 3 round, or I'm all the way, which is just pi upon 3 short of 2 pi. And 2 pi, of course, is 6 pi upon 3. So I'm one lot short of 6, which is 5 pi upon 3. Put them all into order. So it's going to be the smallest one first, pi upon 3. Then it would be pi upon 2. Then it would be the 3 pi upon 2. Then it would be the 5 pi upon 3. Oops, that bit messy. I knew that one came first because that's this angle here, the 270, and that one's coming after it. There it is. And finally at D, a nice little sine. No choice of the sine, sine just becomes 2 sine theta cos theta. And I suppose at the same time I could just have taken that over minus 3 sine theta equals 0. So then I've got common factor, sine theta, leaving 2 cos theta minus 3 equals 0. And from those two factors, either that equals 0 or this equals 0. Now if it had been the other way around, a 3 there and a 2 there, I'd have had a more interesting one. Cos theta equals 2/3 in radians. You just set your calculator to radians and do inverse cos of 2/3 in radians and write down that decimal. And then of course what you'd have had after that would be, since it's a positive, if it was inverse cos of 2/3 you were looking up, whatever that turned out to be, it could be positioned there or there. So it'd either be that number directly or 2 pi minus that number expressed as a decimal. But it's not in this question. I should have done that because I haven't done that anywhere else. It's nice and simple. This just says either sine theta is 0, or cos theta equals, and it'll be the opposite of this, which is 3 upon 2, which is bigger than 1, so it's got no solution. Cos can't get bigger than 1, so no solution, and that's 1.5. So the answer is sine theta equals 0. And if sine theta equals 0, that means theta will be, just think of the sine graph, looks like this, hits 0 3 times, but watch this. So it will be 0, or in the middle, which is pi, or at the end, which is 2 pi, but this doesn't have the equality there, so it won't be the 2 pi. So it'll stop at pi, which means the only solution to this question, unlike the back of the book, is 0 and pi, because that said less than, not equal to 2 pi. There it is, question 9.